Welcome to our Blender tutorial series about sculpted prims. I assume that you're new to Blender, and maybe this is even your first attempt to make 3D artwork. So I will guide you through the process of creating a sculpted prim in easy-to-follow steps. I have chosen to create a top hat. This is not a very complex task, but I can show you many important details regarding modeling and texturing. At the end of this video you will know the most important concepts about Blender, sculpted prims, and about the Prim Star tool, which I will introduce now. I assume that you have already downloaded and installed Blender 2.59, the current stable release. And I assume that you have downloaded and installed the Prim Star 2 software, which you can get from our website. We have already covered these preliminary steps in our installation tutorial. And please take your time to warm up with the Blender interface, for which you will find many tutorials on the web, all that will help you to find your way through this video. We will use Blender's plain and simple out-of-the-box configuration here. I will modify the configuration later to optimize Blender for the creation of sculpted prims. So let us first remove the default cube by pressing X, and then click on Delete. Now we are ready to create a new object by pressing Shift-A on the keyboard, and then Mesh, UV Shape. Here we find a set of basic shapes, which all can be used to make sculpted prims. You can choose among 10 base shapes and a couple of more complex predefined shapes. Since we want to create a top hat, we will select the most natural starting shape here, a cylinder. As soon as you have selected the shape, a new panel opens in the Blender tool shelf. Here you find a set of parameters all preset with reasonable default values. We will come back to them later. But please note that we are working with 8 faces in U, and 8 faces in V, and 2 subdivision levels. You can interactively change the parameters and see right away how your sculptie changes. But note that as soon as you open one of the mesh editors, this control panel will disappear and never show up again. We will see later what you can do with all these parameters. Right now we are in perspective view mode. But when I am modeling, I prefer to work in orthographic view mode. The view mode can be toggled from within the view submenu of the window control bar, or press the keyboard shortcut 5 on the number pad. You can use the middle mouse roll button to zoom in and out. This orange outline of the object tells you that it is currently selected. You can hold down the middle mouse button and drag the mouse to examine the object in the 3D space. As expected, it is a cylinder, and we want to modify it now. So let us switch from object mode to edit mode. You can do that in the mode selection menu, in the bottom line of the current screen. When in edit mode, you notice a few more interesting things here. First, you see a mesh made out of 9 octagons, all stacked on top of each other. This corresponds to 8 faces in X, and 8 faces in Y. If you selected another set of values while creating the sculptie, then you would now see a different mesh configuration here. You also see the cylinder rendered as a smooth object. Indeed, the mesh is used as a set of control points for the cylinder. This is achieved by using a subdivision modifier. You find the modifier configuration in the Properties window, and in the modifier tag. This modifier has been silently added, because we have selected 2 levels of subdivision when we created the object. Please disable the rightmost of the 4 display icons for a moment. Now we can see the base mesh highlighted, while the resulting mesh is shown as a gray object. We also can turn the shading type from smooth to flat. You find the setting in the tool shelf, in the shading section. Now we can see much better how the final mesh is constructed. The subdivision modifier is added to the base mesh, and as its name implies, it will modify the mesh by adding subdivisions. Each subdivision level adds a factor of 4 to the number of vertices. Hence, with two subdivision levels, each mesh point of the original mesh corresponds to 16 vertices in the resulting cylinder. Note that we can only move the mesh points of the base mesh. The subdivided parts will always follow automatically. For now, we just work with the base mesh, and we will learn later how to take more control, even full control over each individual vertex of the cylinder. But for now we are happy with just modifying the control points. Now let us again enable the visual control of the modifier, so we always can see how the resulting mesh will change when we move the base mesh points. Okay, the first thing we need to do is closing the top of the cylinder. For this purpose we switch to front view. You can do this in the view selection menu in the bottom line of the current screen. Or you can use a keyboard shortcut by pressing 1 on the number pad. Now I deselect all vertices of the mesh by pressing A once. Now I want to select the top vertices. Press B to open the border select tool, then click the left mouse key, and while holding the mouse key down, drag the rubber band around the vertices which you want to select. When I now release the left mouse key, all enclosed vertices get selected. Let us check this. We see that not all vertices have been selected, but only the visible vertices. We have to ensure that the icon named Limit Selection to Visible is disabled. You find this icon in the toolbar of the 3D view. Now press B to open the border select tool again, then click the left mouse key, and while holding the mouse key down, again drag the rubber band around the vertices of your choice. Now I will scale all vertices down to 0. Press S. Then drag the mouse towards the center of the selected octagon. As a shortcut, simply enter 0 on the keyboard. Now the cylinder top is closed, but we want to make the top more flat. I go back to front view, and then I grab the selected vertices by pressing G, followed by Z. Now I can move the vertices along the Z-axis, until they align with the next lower octagon of vertices. So we are almost finished. We just need to model that brim. I select the bottom row of vertices and scale them up a bit. Again I use the border select tool by pressing B, left click, drag, and release the left mouse button. Then I scale by pressing S, then drag the mouse, and left click again. Finally I move the whole set of selected vertices a bit upwards to align them with the next higher row of vertices. Finished. Now we need to know how this object can be transported to the target system, namely Second Life. The answer is, we must create a sculpt map. A sculpt map is a 2D mapping of the vertices in your object. This mapping is calculated by Framestar, and automatically translated into an image. And this image can be accessed by use of the UV image editor. All we have to do now, is to configure a split screen and open the UV image editor. This will become very handy in the course of this tutorial. Move your mouse button to the drag handle of any screen, then click on it and drag it. You see that the current sub-window gets automatically split into two windows with the same content. Move the handle around until you have found your preferred window size, then release the mouse button again. In the lower window, go to the window type selector and choose the UV image editor. If the display is too small or too big, you can use the middle mouse roll button to scale it to your needs. And now, we will see Framestar Sculpt Map Baker in action. Fortunately, all Framestar generated sculpties already contain a fully customized sculpt map. And we can make the sculpt map visible in the image editor by selecting all vertices in the 3D view. And, as soon as all vertices are selected, the image editor displays a black square. That's because the sculpt map is still empty. Now, still inside the image editor, navigate to Image, Bake Sculpt Map. And your sculpt map appears in a moment. In the final step, open the image submenu, and save your sculpt map to your hard drive. It is very important to understand that the Sculpt map is stored as an image, typically in PNG or TGA format. But it is not an image, it is a map. This map in fact contains the list of locations for all vertices of your sculptie. And because of that, it is called a Sculpt map. This map is what we have to import to our virtual world. So, go to your second light viewer and import the Sculpt map into your inventory. When you transmit the image, make sure that you check lossless compression, otherwise the Sculpt map will be destroyed, and your sculptie will be distorted. Please take care about the stitching type of your sculptie. For the current object, we will need to set it to cylinder, otherwise we will get weird distortions at the top and at the bottom of the hat. For our first attempt to create a sculpted frame, this result is not too bad. Don't you think? But hold on. Look what happens when I take a closer look under the hat. Not good. The whole object is transparent from the inner side, the brim disappears. Now how can we explain this? Well, the reason is simple. Sculpted prims have only one side. Look here. These are 4 basic shapes for sculpted prims. The plane, nicely visible from one side, but fully transparent from the other side. The cylinder, the outside is okay, but the whole inside is invisible. The sphere and the terrace, these two are okay, but this is only so because they do have only one side. The inner side simply does not exist, hence we see no problem here. So what can we do to make this cylinder work better in our 3D world? Let's go back to the moment where I create the brim. Now we select the second lowest row of vertices and scale them up, as we did before. And then we take the lowest row of vertices, but now we scale them down a bit. Finally we scale down the 3 bottommost rows in Z. The effect is that now we have modeled the brim with 2 sides instead of only one side. And now the hat also looks good from below. Please note that I have not fully closed the hat. As long as the hat is placed on the head, there is no problem here. Only if you intend to hold the hat in your hands, it may become necessary to model the full inside part. We are now at the end of this tutorial. I have shown you how to create a basic shape with Framestar, how to examine the objects, and how to select vertices with the border select tool, and how to scale them. You know how to bake a Sculpt map, and how to export it to Second Life. And now you also know why sometimes parts of a sculptie unexpectedly disappear, and what you can do in order to avoid that. In the next tutorial, we will proceed with a few more advanced modeling tools, and make this cylinder look more appealing. Until then, have fun. See you later.